What up? It's Mr. Shakar. I am here today to go over graphing in slope-intercept form. Okay, so one of the things that we have to remember about slope-intercept form that we got to remember is that there are some really important letters involved in this one. So let's talk about it. Slope-intercept form is y equals mx plus b. So the idea is that m is my slope, and slope is like rise over run. Hopefully that's review. So slope is rise over run, like how much you go up and how much you go over. We'll go over that in a second. And then my b be my y-intercept. So it's where the line that I'm going to graph intercepts the y-axis. And just in case you forget, this is the y-axis and this is my x-axis. Okay, so y-axis, x-axis. So let's go ahead and let's work on graphing in slope-intercept form. I'm starting with this equation. I go y equals 2/3 x minus 4. So the way that I start this one is I start with -4 is my y-intercept. That's my b right here. This is my b. So I'm going to be graphing this in a second. So I have -4 and I'm like 1, 2, 3, 4, blow, son. And then I go ahead and I want to go ahead and find where is the next point. Now this is kind of like the fast hack. You can also create a table and plug in, which is a beautiful method. But if you're just going to go fast and sloppy, this is kind of the way we go. We start with y-intercept, boom, and then we use our slope. So in this case, our slope is 2/3. And as we said, my slope is rise over run. So I'm going to go up 2 from this point, 1, 2, and then to the right, 3, because it's a positive. Now, had this been, it's a positive 3, so I'm going to go positive 3 this way. So I was up 1, 2, and over 1, 2, 3. So I'm right there. I'm going to do it again, almost like steps. I'm going to go up another 1, 2, and over 1, 2, 3. And then I'm going to use my handy dandy line maker, okay, to connect this. And I'm all like, wow, look at this as you look at the back of my head. Okay, so look at that. That's beautiful. Do you see that? Do you see that line? Let's go ahead and do another one because we enjoy this so much. Hey, I'm looking at this equation right here. Y equals -4x plus 3. So in this case, hey, what's my y-intercept? What's my b? Well, it is +3 in this case. And because it's +3, I'm going to go ahead and find +3. I'm like 1, 2, 3 on the y-axis. Now the next thing is I'm looking at -4. Wait a second. Mr. Shakar, I thought you said that my slope is rise over run, like it's a fraction. Well, this doesn't seem to be a fraction. So we got to make it a fraction. How do you turn an integer into a fraction? Well, we just basically put it over 1, okay? Because you are one awesome mathematician that you're going to be able to do that. So now I have -4 over 1. We said that it's rise over run, so I'm going to rise -4, which means, actually I'm going to go down. Okay, so I'm going to go down 4 from this point of 3, and then I'm going to move +1 in the x direction. Okay, so we're going to go down 1, 2, 3, 4, and then +1. And then if I was going to do another point, I would go down 1, 2, 3, 4, and +1, and there I would go, and then I would draw this line. And I feel super good about it. I feel good. You feel good about this? Oh my gosh, it feels so good. Hope you're enjoying this kind of like review or learning it for the first time. Let's see. Now the next one I'm going to do is y equals 5/4 x. And you're like, wait a second, that's an improper fraction. Totes cool, super okay when we're graphing in slope-intercept form. But one of the things you'll notice is like, hey, one of these things is not like the other. One of these things is not quite the same. And that is, hey, this one's got a b. This one's got a b. This one's got a b. This has no b. So what do we do? Well, in the same way that these are in slope-intercept form, this one's kind of something called direct variation. And when there's nothing, bless you, when there's nothing written here, then what we do is we kind of assume that this is +0. Okay? And that tells us that my y-intercept is at 0. Okay? So that means over here at 0 on the y-axis, okay? 0 on the y-axis, which we also call the origin, all right? We put a point right there. And next, I'm going to apply the slope. Again, I'm going to go up 5 and over 4. So I'm going up 1, 2, 3, 4, 5, and then over 1, 2, 3, 4. Remember, it's always rise over run. Rise over run. Rise over run. Okay? And then I'm going to go ahead and I'm going to connect these points. Connect the dots. La, 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 la. Connect the dots. La, 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 la. Good. So remember, when you're graphing in slope-intercept form, the first thing you have to do is, what is your y-intercept? Okay? Plot that y-intercept. And once you do, then we apply the slope, which was rise over run. Rise over run. And then you're like, Mr. Man, there's no rise over 1 here, and then we put it over 1. That's the thing we can do. So, yeah, that is graphing in slope-intercept form. Hope that's great. Enjoy doing it with you.
What about inequalities?
Inequalities? You want to learn about inequalities? Okay, we can also graph about inequalities. Fine, we can do that. All right, so graphing inequalities is something else we can do. It actually starts in a very similar way. And we're like, how similar? Let me show you. So this idea is that I have an equation, not an equation, an inequality, where we have y is less than 2/3 x minus 1. So I'm going to do it the exact same way. I'm going to start the exact same way. So I always, like I just told you, I start with graphing the b, okay? But in this case, we have -1 as my b. So I'm like down here at -1. Wow! I plot that point. And next, I go ahead and I look at my slope. My slope is 2/3. So that means I'm going to go up 2 and then +3, okay? Because it's a positive. So I'm going to go up 1, 2, and +1, 2, 3. Booyah-ka-cha. And I'm going to go ahead and graph that, hopefully with something that's a little darker so that you can actually see it. All right. Now, oh my gosh. Now, this is where inequalities are a little different. So this is super exciting. Now, well, exciting for me and for you because you're about to learn it. The idea is that it's not equal. It's an inequality. And y is less than 2/3 x minus 1. It's not equal to. And because it's not equal to, the solution is not part of the line, which means that the line is hollow. How do you graph a hollow line? I'm so glad you asked that. The way we graph a hollow line is that I'm going to graph it as a dotted line. All right, so I have this dotted line. When you graph inequalities and it's not equal to, it's just less than or greater than, you graph a dotted line. Everybody okay with that? Now the next part is that I have to go ahead and I need like a test point. I need a point on this graph that I have to be like, is this a part of the solution region? Because you don't have just one answer for inequalities like this. You have a whole bag of answers. In fact, we shade either the whole top half of the plane or we shade the whole bottom half of the plane, okay? So the idea is that I need a point to check. Now the easiest, laziest point to choose, because I'm all about being lazy. Look at this body. Anyway, the idea is I love to check 0, 0. I love to plug in 0, 0 into this inequality. All right? And then I check to see if it's a true statement based on once I plug it in, is it true? Okay, so where do I get 0, 0 from? It's this point right here. I'm kind of like plugging it to check. So what I get is I'm going to plug in 0 for y and 0 for x, which will tell me 0 is less than, hey, what is 0 times 2/3? Oh, it's 0. And then what's 0 minus 1? It's -1. So is it true that 0 is less than -1? No, 0 is not less than 1. So what that tells me is that 0, 0 is not a solution to this inequality, and therefore I do not graph the side that contains 0, 0. I graph the side that is away from 0, 0. And so I go ahead and I shade all of this business on the opposite side of 0, 0. All right, let's go ahead and do another one because maybe that one didn't click yet. So I'm happy to do some more. Again, this one, okay, so this time I have y is greater than or equal to. So I got that line underneath. And because it's equal to, my line's going to be solid this time. You good on that? So the idea is now I have -3x plus 1, all right, in this case. So where do we always start? We always start with the y-intercept. In this case, it's +1. So I'm like, blow! And then I need to go ahead and apply this slope. Wait a second, that's a whole number. What do we do when we have a whole number for a slope? We go ahead and put it over 1, all right? So now I have a slope that reads -3 over 1. So that is a rise of -3. In other words, I'm about to go down 3. So I'm going 1, 2, 3. So I've gone down 3. And then over 1 in the positive direction, okay? And so then I'm going to go ahead and connect these. And because it's greater than or equal to, that equal to part makes this a solid line. All right, cool. But now I have to go ahead and I have to check which side of this graph do I shade, okay? Because if there's one thing I enjoy, it's throwing shade. So this idea now is I have to plug in my test point of 0, 0. 0, 0! I need to know if 0, 0 is a part of this graph. So I plug in, is 0 greater than, hey, what's 0 times -3? Oh, it's 0. Okay, so +1 is 1. Is 0 greater than 1? No, 0 is not greater than 1. So because 0 is not greater than 1, this again is a lie. It is not part of the solution set. 0, 0, x is 0, y is 0 is not part of the solution set because it doesn't make sense, all right? Then that means I shade away from it. That means I'm shading all this business up here, okay? This is all shaded, okay? So let's move on to the next one. The next one, again, how do we begin these? Well, we start with the y-intercept. Oh, there's no y-intercept. So it's going to run through the origin. So I'm going to go ahead and plug in. It's going to be 0. And then I go up 5 over 2. Up 1, 2, 3, 4, 5 over 1, 2. And then in this case, there's no line underneath, so it's just y is greater than. That means that it's a dotted line. Just like this one was a dotted line because it's not less than or equal to. This one was greater than and equal to, so solid. This is just greater than dotted line. Okay, cool. So let's go ahead and do that. All right, so that looks beautiful, all right? And it's good to praise your own work. So let's go ahead and we need a test point. So my favorite test point is 0, 0. Let's go, I can't plug in 0, 0. Why, Mr. Shakar? Why can't you plug in 0, 0? Well, it just so happens that you can't plug in 0, 0 because it's on the line. You can't use the test point on the line because it'll give you false positives or false negatives, all right? So we need to find something else. Another point that's not on this line. I wonder what I could use. So I'm going to go ahead and I'm going to plug in, I'm going to make up something that's not on this line. I really like the idea of, I'm going to plug in 2, 0. I'm going to plug in this as a test point. How'd you decide your test point? You just decided test point. And something you feel comfortable plugging in. So I'm going to plug in the point right here, which is 2, 0. And I'm going to see, is that a part of the solution set? And the way I do it again is I plug in 2 for x. So I'm going to go 5 halves times 2 is greater than, and then for y I'm plugging in 0. So then I'm going to go ahead and I'm going to start just mathing this out. So I'm like, hey, what's 5 halves times 2? Well, these bad boys will cross cancel to basically give me 1 and 1. Hey, what's 1 times 5? 5. What's 1 times 1? 1. So what's 5 over 1? It's 5. All right, so 0 is greater than 5. Is that true? No, 0 is not greater than 5. You know, I chose these at random. I didn't mean for all of them to be false statements. But what this means is since 0 is not greater than 5, that means that this is not part of the solution set. Because it's not part of the solution set, that means I shade away from it. If it was part of the solution set, I would shade to include it. Okay? So, I'm shading away, Shakar throwing shade, favorite pastime, and there I am. So, there is a video not only graphing on slope-intercept form, but also graphing inequalities utilizing the same methods. I have had a great time, and I've totally enjoyed having you here. Thank you for being here. Thank you for being awesome. Thank you for mathing it out. Thank you for loving unicorns. I hope you guys have a great day. Peace. See you later.